Okay, we are recording. Okay. Hopefully we are recording. Okay, great. So the question that I ended last day with, let people join, and then we can continue with today's material. Was I told you to sample from a distribution x plus y less than equal to 1, where x comma y was greater than equal to 0. I told you to sample from this distribution points uniformly, and we found that it was not happening because we were sampling uniformly from x. So I had sort of made a small error there. I'll just draw your attention to it. See, if you sample uniformly along x, all these cross sections will have equal number of points along the y, and hence you will see a more density along places where you don't have much to put y's, right? Is the problem clear? So we were sampling uniformly along x, and I told you then convert it into uniform 1 minus y. So that was the issue. So if I'm told you have to sample fx comma y, and you know these two distributions already. So fx we found out last day was the marginal distribution was 2 into 1 minus x. So you only know to sample from uniform distribution. So what will you do? How will you sample x and then in turn get x given y? So for example, so here y is given. So let us make this y given x. Yeah. What will I do? First step, I will have to sample from x, right? Step one has to be, as Brahmojit also has done in one of the examples, sample from x. And then two would be sample from y given x. Any doubt? If you have doubt, you ask, or else I'll just do the math. So these two steps, if you do, you will get x comma y as a sample from fxy. That's the idea. So if I ask you, how will I get samples from x? Can anyone tell me?
So we can randomly sample from 0 to 1.
No, but then I told you the problem, right? So this is be the problem where you will have more. It is not x is not uniform 0, 1. Na? Understood the problem. So you will have more equal number of data points along these bins along y. So you will have more dense number of points here compared to somewhere here. Understood?
So can we use a
So
function
you'll
that
have
has
to sample and according to f of x. So if you recall, so f of x is given to you is 2 into 1 minus x. So how did we sample from f of x? We sampled from uniform, and you only had submitted that homework. We sampled from uniform and we took f inverse, right? Capital F inverse, or the CDF's inverse, right? So what is the CDF here? 0 to x 2 into 1 minus x, right? This is the CDF. The probability that y or x less than equal to x, correct? Where x is between 0 and 1. Do you agree with me?
yes, Dada.
So what will I get? So this will become 2x minus x squared by 2 into 2. So this is your x into 2 minus x. This will be your CDF. So CDF is, and x is between 0 and 1. Right? So between 0 and 1, it is a 1, 1 function. So I will be able, what do I need to do next to sample from uniform and then sample from x? Utrish, do you remember what do you need to do next? So we need to sample from u and take f inverse u, right?
So what we can do is I can randomly pick up samples from the uniform distribution and then put it to this equation.
This is f of x, but you need f inverse, right? F inverse of x.
So I can
We took,
equal.
you have to find the inverse, right? So how will I find the inverse? This is the inverse. Yes or no? How this is how I'll find the inverse? Minus x minus 1 whole square plus 1. You make y the subject and then it becomes inverse, right?
I represent y in terms of x. That is the inverse.
Yeah, that's what I'm doing. So x minus 1 square is equal to 1 minus fx of x. So you get x is equal to 1 plus minus 1 minus fx, right? So you see, now I know how to sample from x. What will I do? This is your f inverse. F inverse of u is nothing but 1 plus minus 1 minus u. You will see that you cannot take the plus sign because then it will be between, f inverse is mapping between 1 and 2 then. So 1 and 2 is not what we need, so we'll take just the minus sign. Agreed? So now your x is equal to f inverse u. This is also in your homework. Please try it. So f inverse u, just sample from u, plug it into it. You will get samples from x, and then you will sample. So first step 1 will be u will be uniform 0, 1. Step 2, you will take the u, put it into this, and step 3, you will sample from y given x as uniform 0, 1 minus x, right? This is what we did.
There's something is
Yeah,
not
tell
clear.
me.
Here,
Yeah, tell us.
till this expression 1 plus minus root over 1 minus fx x, that expression,
Hmm.
then
Hmm.
fx was the CDF of the uniform.
Fx was the CDF of the uniform, right?
So when I'm coming here, f inverse of, then we are writing x as the f inverse of, what is this function?
X, when you have a function y equal to f of x, right? X is nothing but f inverse y, right?
Okay, yes, that is clear.
Correct. So now how do you find inverse? So you find inverse by making x the subject and y the predicate, or whatever. You make y the,
I express y in terms of x.
yeah.
So the
So
other
that's what
one.
I did. So x in terms of y, you mean?
Yes, yes.
Yeah. X in terms of y I expressed just now.
That is what we got. X equals 1 plus minus 1 minus fx, that expression.
Yes. Now that is your f inverse x. Do you agree? So if
That
I
is the
write
that's
this as,
okay.
yeah.
That is
So if I just make u the random variable, make the u the variable, so I'll just putting u instead of fx.
okay. That is clear. So when I'm actually trying to plot this thing, so what I'll do is I'll sample from the CDF of the uniform, I plug it into this equation and then plot this, whatever I get.
Yeah.
Okay, now it's clear.
That's what we have done. So you only sampled that and showed.
Yes, I sampled that in the previous week.
Yeah. Okay. So similarly, you can sample from any distribution, just have to take the inverse. The inverse function you'll have to take and put samples from u and then plug it into it. Right? Understood?
Yes, Dada.
Okay. So
Dada,
now
can
we'll come to the, yeah.
yeah, means can you briefly say means what is the advantage we are getting on taking the inverse? Means I understood that within small range uniformly, if we get take samples, it will become more dense. That part okay, but what is the advantage on getting the inverse?
So
Taking the
you don't know
inverse.
to sample from x, right? Do you know how to sample from x? Like along this x line, do you know how to sample? How to get a point on x? What distribution will you choose? Can you choose uniform 0, 1? You cannot do that. That you understood, right?
Yes, yes,
So you will have to sample according to f of x, right? We had done this in quite extensively when we showed that uniforms are universal, right? You can sample from uniform and get any other distribution, right?
yes,
So how will you, what did we do? We showed that the CDF, the distribution of the CDF is uniform, right? We showed the distribution of
Yes.
the CDF is uniform. So if order to get the values from X, we just need to take the inverse of the CDF, right? So we will take the inverse of the CDF, plug in a uniform 0, 1, samples from uniform 0, 1, and you'll get samples from X.
Yes, understood.
Now you're doing is you're so Oshmit, this is what we were discussing regarding the question that you had solved, and I told I'll discuss it in the last day. Please go back and have a look when you are. So I took the F inverse and then sampled you. Understood now, Oshmit, that we'll have to first Outreach. Did you understand the solution I had shared?
Yes, understood.
If you haven't, please go back and look at it. How we are sampling from any distribution if you only know to sample from a uniform distribution. Okay, so now we'll begin with today's class, and this is probably the last section on statistics. And it is the most interesting part of what we have now. We are going to apply what we have learned to more advanced and real life problems. So to do that, we'll have to deal with two very well-known distribution. One is known as chi-square distribution, and the other is known as t distribution, and the student t distribution. Your board's marks, your gate marks are all scaled according to that student t distribution, and there are so many use cases. So first, let us see what is the chi-square distribution, and then we'll go to more advanced distributions. Okay, so Oshmit, did you see the solution that I had shared?
Yes, Dada.
Just give me a minute. Okay. So now let us begin with the first distribution of today, which is also known as the chi-square distribution. So V is written as Z1 square, Z2 square, dot, 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 Zn square. Then V is told to be distributed as chi-square n. Okay. So then this is known as the distribution of V. Right?
Here Z are IID.
So this is the definition. Is it clear to everyone? So definition ZIs are normal 0, 1 distribution, as we have seen always, all this while, right? Okay. So now I'll give first, let us to warm up. Let's do a simple example. That is, let us try to find the distribution of chi-square 1. Find distribution of chi-square 1. How will you find it? If you have been following all along,
So it is
how
the
will
square
you?
of n01. That is it.
Good. So so chi-square 1 is, let us denote this as V1 as Z1 square, right? You're okay with it? Okay. So
Yes,
now,
Dada.
if I'm told to find the distribution of V1 less than V, how will I find? So this is what your distribution is, right? So if it's going to be transfer of random variables, transformation of random variables, but we cannot use the formula directly because it's a many to one function. Recall, x and x square is a many to one function. We needed a many to one function to use the transformation CDF formula. So let us define from the first principle. So V1 less than equal to V. So what will I do next step? What will be the next step?
So this is a summation of
Yeah, tell.
these v ranging from 0 to v.
So z square would be less than equal to v, right?
Z square
We have
less z less
defined.
than z
Good.
square less than equal
So
to v.
so z would be between 0 and root v. Yes or no? Twice into. Yes or no? Why did I write this? Let me just write once again. Not people are not doing, say, seeing my sessions, and that's why you're not following. Yes, right or no? So just a moment, I make tab is disconnected. Yeah, now I think you'll be able to see. Right? Z would be between. Yeah.
You have taken the root.
Tell me.
You have taken the root here. Yeah, that is it.
Yeah, just taking the root. So Z has to be between minus root v to plus root v. Yes or no? So if you recall, the distribution of a normal is like this, right? This is your normal 0, 1. And this is your Z. So if it has to be between v, it can be both sides, right? If the value is v, it has to be between v, the Z square has to be between v. Z can be between minus v to minus root v to root v. I think there's no doubt regarding that.
And
So then,
since it about the y-axis, you have taken into 2.
yeah. So this is a this is a what is it? A even function, right? An even function. CDF is an even function. Symmetric about x y equal to 0, x equal to 0. So you will get 2 into integral of e to the power of what is the CDF PDF of a z? How will I calculate? What will the integration be?
E to the power minus z square by 2.
Z square by 2, 1 by
1 by root 2 pi.
so this is your FV of V. Now I've told you to find the PDF. How will you find the PDF? From this CDF? How will you find the PDF? The density function?
You can differentiate.
So you'll differentiate both sides with respect to V. Okay. So if I differentiate both sides with respect to V, on the right hand side, I'll use the Newton-Leibniz formula. What will I get? 1 by root 2 pi e to the power of minus V by 2 into ddV of root V. Correct? By chain rule? Yes or no?
Yes.
Now, did you understand? This is going to be your distribution of Z square. So chi square 1 or Z square, where Z is normal 0, 1. Z is normal 0, 1. Then the distribution of chi square 1 is an exponential sort of a function, right? So you will have something like, how will it look like? How will the CDF look? It will look like at 0, it's going to very, very, very high values, infinity, and then it drops to 0. Correct? This is your chi square 1. Right? I'll wait for 1 minute, and then if you have any doubts, you interrupt me. Otherwise, I'll go to more applications of this. Okay, so no questions. So we have found what is the distribution of chi-square 1. Now I have told you to find what is the distribution of chi-square, expected value of chi-square 1. What is the expected value of chi-square 1? Say if I tell you expected value of chi-square 1 is nothing but expected value of z square. Now tell me what is the expected value of z square. You shouldn't be able to solve. You don't need to solve the integral here. You don't need to do this integral. Without even doing the integral, you can tell me what is the expected value of z square, where z is normal 0, 1. What will I say? What is variance of z? Variance of z is 1. Right? We define mu sigma square as the normal distribution. After doing so much normals. Okay, then what is the variance formula? What is the formula of variance?
Ez square minus Ez. Expected value of z square minus Ez square.
So what is the expected value of normal? What is Ez?
0.
0.
So expected value of z square is 1, right? The expected value of chi square 1 is equal to 1. So the distribution we are currently looking at is a generic distribution, which is sum of n normal distributions. We are currently at the as the base case, that is the what happens when the number of normals is 1, and we found out the distribution of that, and we found out the expected value of that. Variance for all these cases is your homework. Please go back and find the variance of all these distributions whose expectations we are finding. Where is it? Yeah, expectations we are doing. This is homework.
See the calculation of variance of chi-square 1. How you did it?
I have not done variance of calculations. This is only calculations. Please go back and do it. I'll help you with a mgf, and then you may be able to use the mgf directly to do the variance, right?
Acha,
I have done only expected value of chi-square 1.
okay. So E of a z square. So
See, okay, so if you people who have joined late, so chi-square 1 is e of z square, right?
yes.
Just z square. Now we found the distribution of that. So the distribution is the CDF. The CDF of V is V less than V, right? From the definition.
Yes. Yes.
So I wrote z square less than equal to V. I just replaced, because I don't know the V's distribution. I know Z's distribution, right?
Yes.
That's why I replaced V by Z. Now, if Z square is less than V, then Z has to be between minus root V to root V.
And then since it is symmetric about the y-axis.
Exactly. Good. So you will do an integration from 0 to root V, 2 times that, and then just take the derivative with respect to V, and you will get the distribution. It's a nice distribution. It's an exponential divided by the root of the exponential, right? Exponential x, exponential is minus x by root of x. It's a good distribution. At 0, it's not defined, but it goes to asymptotically to 0. And we found the expected value is 1, right?
Did you use Leibniz in that part?
Yes, Newton-Leibniz formula I used.
Okay.
Yeah, so expected value of chi-square 1 I have found. Right?
Yes.
Now, if you are following my classes till today, what is expected value of chi-square n? First step, what will I do? The first thing that we started. Yeah, tell me.
Break expectation with linearity.
Very good. So I will write a chi-square n as n normal distribution sum, right? As I have defined before.
Yes.
So all our IID is, so I'll get n into expected value of Z1. So which is n. You can also find the variance of chi-square n. You will see it is equal to 2n. This is your homework. But you can easily find after I find the CDF of the or the mgf. So we have found the expected value of this. Now let us see what happens if you take sum of chi-square. This makes the distribution very important. So when you're taking sample variance and so on, all those distributions are chi-square distributions. I'll show you why. This is the most important distribution in this and the t distribution in your using statistical analysis from data. For doing any analysis from data, these two distributions are the most important. Okay, let's see. So V1 is chi-square n. So this is a one property one. So we're discussing some properties of the chi-square. The first property is V1 is distributed as chi-square n, and V2 is distributed as, say, chi-square m. What is V1 plus minus V2 distributed as? So V1 plus minus V2 is
Plus
summation of,
chi-square m plus n minus 2n.
so chi-square 1 to x to 1 z square, right? Where is it? Zi square, correct? Plus minus I equal to 1 to m z j or j equal to 1 to m z j square, right? Do you agree?
Yes.
Okay. So what would be the expected value? What would be the variance? And so on. So expected value and all, just to get an example, intuition, we'll see by the moment generating function. Expected value would become n, and you have the expected value of this n minus
m.
plus minus m, right? Correct?
Yes.
So, and similarly, variance would be, so variance would just add up. So you would not essentially get, for minus, I think it won't hold, but still we'll look at it. But for plus signs, it will hold. For example, variance of V1 plus V2 is still going to be m plus n, as we have seen, 2 into m plus n. We have seen it this before. But variance of V1 minus V2 is nothing but variance of V1 plus V2, right? Because minus does not matter with the IIDs. So you will have variance is just going to be always positive because you're increasing the variance. So even in this case, it is going to be 2 into m plus n. So this is not really going to be a chi-square in minus case of minus, but V1 plus V2, you see. So as Partho was telling me, V1 plus V2 will be clearly distributed as chi-square m plus n, right? Minus is not going to be chi-square m plus n because it's, you are clearly seeing expected value is different.
Is
This is
there
not
any
going to.
for
Is there
minus?
any?
Is
Is
there
there
any
any
is there any name for the minus
for?
one?
There is no name. I don't know what is the distribution. You have to find it using MGF. So we'll leave out the minus for the time being. Just consider plus. For simplicity, we'll just consider the plus. I just wanted to show you the minus case. So minus is not a chi-square. Not chi-square m plus n or chi-square m minus n. Neither of these. Okay. So we found out that the sum of two chi-square is also a chi-square, just like normal distribution, right? And it's just like adding some terms to the chi-square. So if you take m and n to be degrees of freedom, these are called degrees of freedom. So chi-square n is known to have n degrees of freedom. We'll see why. So if you add two chi-square, you just add the degrees of freedoms, okay? So this is one property. So we define one property. The second property, this is very important for t-tests. We'll see why it maybe today or early tomorrow next class. It's very, very important for t-tests. So I'm just creating all the tools that I need to show you the distributions. What is it? What are these tests and so on? Okay. Now I'm telling you to find the MGF of this. So let's quickly leave out some space here for the t distribution and just go to the end. Yeah. So chi-square n. What is the definition of chi-square n? Others? Just to see if you are on the same page.
Summation of zi square from 0 to 1.
Summation of zi square I equal to n. N is the degrees of freedom. Others who had exams, please go back, finish the statistics part, go and solve the questions, please. By now, you should be able to use these properties very easily if you are following. Okay, so I have asked you what is the MGF of V. So if I ask you what is the MGF of V, people who have been revising, what is the MGF's definition and why is it important? Property 2, MGF of, yeah.
For T.
Okay, why is it important? What did we say? If
Because
moments,
the
if
MGF is unique for every distribution.
matches, the distributions match. Also, this is one. This is the usefulness of MGFs. And the second usefulness is you can find all moments from it, right? Find all moments. Expected value of. This is why I told you if I go home and find the variance, I'll give you the moment generating function. You can just take the so x to the power nth moment is nothing but the nth derivative of the MGF, right? So we have defined t equal to 0. We showed this using Taylor series. Right, these are the usefulness of the MGFs. You take the nth derivative and put the t equal to 0. If you don't recall, please go back and see how to expand using Taylor series. Good. So now, as Partho was telling me, this is going to be t into v, expected value of tv, e to the power tv, right? So now what will I do? What will be the next step? I have done this numerous number of times when I was doing central limit theorem. What will I replace v as? What is v? What is vn? Let's me write n in case there is a confusion.
We replace this as the sum of z1 square z2 square.
Good. Now then, what will I have? These are IIDs. How will that help me?
So now I can
Basically,
split
we
it
can
into a series of products and take
Correct.
expectation individually.
So you will get Z1 squared and you will get n terms of these because they are IID, independent and identical. So expected value of xy for independent events is nothing but expected value of x into expected value of y. We have shown this property before. And then, so we get the MGF, right? So this is my MGF. But now you're asking me the MGF of z square. But I don't know, I only know the MGF of the normal distribution. So I am in a precarious situation, how to solve. So what will I do? E to the power z1 squared. I will write the integral down. So what is the integral? So what is the PDF again? What will the integral be? Let me see. Can you use Lotus correctly? Use Lotus. So what would be the integral over? Yeah, tell. E to the power. Yeah, tell. Your voice just cut in between.
z1 square.
Let's take a dummy variable z instead of z1 square.
Z square z dz.
Expected value of what is the distribution of z1? Normal 0, 1. You're using Lotus. So into the
Oh,
PDF.
into 1 by root 2 pi e to the power of minus that one.
That normal distribution should be, you should be able to write in sleep also. It should be by heart. So if anything in the world has to be by heart, the normal distribution CDF has to be, PDF has to be by heart. That's the only thing you have to remember. E to the power minus z square by 2, right? From minus infinity to infinity. Okay. Is this okay? Is the expected value clear? Okay, if it is not
Yes.
clear, I'll ask a simple question to each of one of you. First question: what is the function that whose expected value we are trying to find? First, what is the function? Yeah, tell.
We're trying to find the expected value of z1 square.
E to the power 2z1 square. Good. Now, O3, what is the distribution over which we are trying to find the expected value?
Okay, Z1 of Z1, that is normal 0, 1.
Correct. So this is a function. Remember that again, this is a function. The distribution is only coming in at the PDF. That's why I took a dummy Z instead of taking a Z1. So in case people may get confused, so Z is a dummy for the integration. But you're actually finding the expected value of that random variable. So you sample a random variable, put that value on that Z1, and then you will calculate the integration. Okay. So how will I integrate this? 1 by 2 pi z squared tell what is the sum you'll get. So you'll get t z squared t minus half, or say half minus t. Yes or no? Right? I just wrote the integral together. Now, people who are confident about integration, what will I do? Which integration do I know? Which integral can I do?
E to the power of minus z squared by 2 we can do.
Yes, so I can do this integral. I know to do x square by 2 dx. I know this. This is equal to 1. We know. Why is this 1? Ushmit, why is this 1? Because this is the
Gaussian,
this is Gaussian distribution.
Gaussian distribution, yes.
This is the PDF of the Gaussian distribution. So you're taking the total probability. So that is equal to 1.
Yes, yes.
So how will I convert this to this?
So
Simple.
we can take root over half minus t as k and that multiply.
Or I can just take what? Yeah. So you're telling root over half minus t as k as x. X by root 2 or something. How will I convert this? I will take this to x by 2. Right? This is what you're saying. So if I square both sides, I'll get a numerator of z square, right? Minus of, am I doing it correctly though?
আচ্ছা ওটা x by square root of 2 হবে না?
X by square root of 2 where?
না, if you had taken the square root of half minus t into z is equal to x by square root of 2. So in that case, once you had
No,
squared
no,
it,
I will try to substitute this value, right?
Yes.
I will try to make this equal to x by 2 some way. So the x square by 2.
হ্যাঁ ওটা তো x square by 2
ওই x by √2 হবে, মানে half minus t
Yeah.
root over
So I will
into z into equals to
yeah.
x by
So
root.
x by 2. X by √2. This, right? So see. So I'll get half minus t. So this is just a intelligent integration trick. Z square is equal to x square by 2, right? So my numerator is solved. The problem with my numerator is solved. So what is dz? My dz is x by dx by 1 minus 2t, correct? Any questions? Any doubts? Okay. We could have also used the distribution of the chi-square 1. That would have made it much simpler, but this will also do, I think. No worries. Hope this is okay, right? So next, what will I do? This will be the integral from minus infinity to infinity. 1 by 2 pi. This is much simpler though. When I did it using, I had done it using chi-square 1 and it had been a longer calculation, right? Is this integration now correct?
ওখানে
Agree?
1 by square root of হবে না?
Root 1 minus 2.
Square root I have put. I think it has not come yet. I have put that. Right or no? Is this okay?
Oh yes.
Yes.
So this will go to 1 or not? So you
1.
can do the same question multiple times. I only to solve it 2 ways in few days. So this is 1 minus 2t half. Okay. So this is your mgf, agreed? Of v of 1. This is chi-square 1's mgf. What is the chi-square n mgf then? Mgf of chi-square n? This 1 by 1 minus 2t to the power half whole to the power n, right?
Yes.
So now see, this is very useful. So this you have to tell me there is a condition for t here. What will the condition be?
T not equals to half.
Is greater than half.
Or less than equal to half, right? So this is a condition, but that is not
The equals will also
equal
not
will also
hold.
not. No, it will not hold.
Infinity যাচ্ছে.
Yeah. So equal I have not put. See. Okay. So is it clear? So we found out a brilliant property of chi-square n of t is it equal to 1 minus 2t to the power n by 2. Remember this property very clearly because I'll use in a particular very interesting formulation now. Is this clear to everyone? Power chi-square 1. So do you agree this is equal to z square? I can also write as expected same thing as expected value of e to the power of chi-square 1. Yes or no? If now the distribution is over chi-square 1. Right? Try to do this also. So in that case, you will have e to the power tv and you will have the integral of e to the power tv into e to the power minus v by 2 pi v integral from 0 to infinity dv, right? This way also I can solve, right? Your numerator z square is nothing but chi-square 1 and we found the chi-square 1 distribution, yes or no?
Yes.
Think about it. Once you go back, think about this. This is also your homework. Try and solve it this way. Good. So now my last property, which is very important property of a chi-square distribution. So we have shown all these properties, sum of chi-square, mgf of chi-square. The third and the most important property. So the use case, as I was telling you, comes from this property. The use case is that when you have sample variance, you recall what we did last class? We defined a unbiased estimator of the variance of a distribution. You recall, right? And we
Yes.
showed it is equal to 1 by n minus 1 summation of xi minus the sample variance, sample mean, right? We have to show that this is equal to chi-square n minus 1. That is, degrees of freedom is n minus 1. And this is used everywhere. So if you are taking if you are doing z-scoring, or you are normalizing the data as x minus mu by sigma, as we had done before, recall, right? So we know that. Let me just show you the intuition. Use case of chi-square. So do you recall? So chi-square, do you recall x minus mu by sigma was normal 0, 1 if x was distributed as mu sigma normal mu sigma square? We had derived mu sigma square from normal 0, 1 this way, right? Correct. So x is your normal mu sigma square, and z is normal 0, 1. Do you agree? So they were related this way. But in reality, do you have access to mu and sigma? You will be given samples from this distribution. So you will know only x1, x2, dot, 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 xn, and you will have to estimate the mean in some way. And also the sigma standard deviation will also have to be a sample variance. So sample variance, as recall from last class, we defined an unbiased estimator of sample variance, unbiased estimator. We derived it. We found out why it is an unbiased estimator, because Utrish, do you remember why is it an unbiased estimator? If I define
Yes,
Sx,
because we multiplied that factor to the biased one to get it.
now what is an unbiased estimator? The expected value of that is equal to the actual variance, right? This is sample variance, right? Sample variance is a random variable, but because you are taking it over samples, as we had seen, x1, x2, xn are IID random variables we had taken, right? And we had taken the expected value, and we saw that it was equal to the actual variance if we chose Sx as what we have to choose the sample variance as 1 by n minus 1 I equal to 1 to n xi minus x hat, right? Where x hat is equal to 1 by n I equal to 1 to n. You remember this? This is the mean, sample mean, and this is unbiased sample variance. Yes or no? We defined this last day. Any doubts till now?
Yes.
And we showed if you take expectation on both sides, this turns out to be variance of x1 or sigma squared. We had shown this. So this is our required sample variance. So now if I ask you, I'll give you a hint. N minus 1 into Sx squared by sigma square. What is it equal to? So again, to recall, x1, x2, dot, 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 xn is distributed as some normal mu sigma squared. We are assuming this. Or by central limit theorem, they would essentially be normal mu sigma squared. The mean will be. We'll see why. Right? So they are distributed as normal mu sigma square. and variance of xi is equal to sigma square, expected value of x1 is equal to mu for each of them. So do you see the right hand side is equal to xi minus x cap x hat by sigma square whole square, right? Yes or no?
Yup. Yes. Yes. Yes.
And this is an unbiased estimator of mu, mean. Because we know expected value of, what is the expected value of x hat? 1 by n into expected value of, yeah. So it's equal to mu. Now, what is this looking like? Do you agree this is equal to zi square? Very similar to a square of a
Yes.
normal. Now your right hand side has become a very similar to a chi-square distribution, but we do not know its parameter. You would expect it is n because there are n terms, but let's hold our horses. It's not n. It's not n because we are taking sample mean, right? We are taking sample mean. Yes or no? And not the actual mean. Had it been the actual mean, you would have chi-square n. Yes or no? So I'll ask you a question. Yeah, tell.
That I didn't understand. Means, why did you say that since I've taken the sample mean, I can't write it as a chi-square n?
So it is not chi-square n because sample mean is, do you agree it is equal to summation of 1 to n xi? Yes or no?
Yes.
So it is biased towards the samples, right? So this, if we are taking xi, that xi is also there in x bar.
Yes.
That, so it is no it. So if I ask you, let us ask this question. What do you think about this distribution? Summation of I equal to 1 to n. Well, how is this distributed as? Anyone else? Other than Partho? My first question is, how is x minus mu by sigma distributed as?
Normal 0, 1.
Normal 0, 1. So how is this distributed as? The summation from 1 to n. So this is essentially writing zi square I equal to 1 to n, right or wrong?
Yes.
This is chi-square n, right? This is your chi-square n. There's no doubt. Sum of n square normals. Okay. But here you don't have the actual mean. You have a sample estimate. In this case, where we are trying to find it for a, what is the distribution for the, so we are trying to find distribution for sample covariance, sample variance. So you see the distribution of sample variance has sample mean in it. So it is not exactly chi-square n. We were talking last day that it has some bias, right? Poshmith had told me that there's a little bias as far as I remember. So now let us see how can we find out the actual distribution of, so our interest is, so sx squared n minus 1 sigma squared is 1 to n xi minus xi cap whole square, right?
Tata, this means bias would disappear if n is very large. So that is why
Correct. Very good.
Okay.
N is very
N
large.
is finite, so that is the problem.
Yes, n is finite. That is the problem. You will see in T distribution how this bias is affecting. We will see today. You will feel the feel good factor that everything will become a circle. We'll see how the bias will disappear when you go to infinity. But till now it is clear, right? We need to find it for the sample term. So now how can do you know a trick? So first, what do I need to show? I need to show the mgf of this. So let us represent this as R, the required distribution, the Haled distribution. So do you agree to show that it is some chi-square? Your aim, we need to find the moment generating function. Yes or no?
Yes, we need to find the mgf and show that it is identical to the mgf of chi-square.
Some chi-square, yes. And then we'll get the parameter of chi-square also. So see the beauty of mgf. It will give me the parameter of chi-square. It will give me everything. Once you understood grasp.
I assume the chi-square whole to the power of p, then I can equate them to find
You
a P.
cannot, because they are not equivalent. They are not independent. You will do that. But here you see it is not chi-square, right? It has sample mean. So what can I do? What trick will I do? I'll do a simple trick. I'll try to break this up into two sums. Let's see how do I do that. Last time we had done a long calculation, but this time it will be a bit simpler. Just see, can I write this way? I equal to 1 to n xi minus mu by sigma minus xi bar or x bar minus mu by sigma whole square. Can I write this way? Is it clear? I just added and subtracted the actual mean. This is the actual mean, right? Any doubts? This is the step. After that, it's all algebra. Is it clear, this step?
Yes.
So now what will I write this as? 1 to n xi minus mu by sigma whole square plus summation of I equal to 1 to n xi minus mu x bar minus mu by sigma whole square minus 2 into I equal to 1 to n xi minus mu by sigma into x bar minus mu by sigma. Okay? Yes or no? Is it okay?
Yes.
So now you tell me the first term stays as it is. Do you see that we are getting the term that we liked? X minus mu by sigma. This is normal distribution now, right? This term, can you tell me how can I? So x, this term is a constant, right? It's a sample mean, does not depend on I to 1 to n, doesn't depend on I, right? None of
Yes.
these terms depend on I. So it is, do you agree? This is equal to n times x hat minus mu by sigma whole square, right?
Constant, yes.
Yes. So in this term, this is a constant again, does not depend on I. I can take this out and I'll get minus 2n. Yeah, tell.
0 হয়ে যাবে তো ওটা,
কেন 0 কেন হবে?
because the summation over xi on না না না
Mu is the actual mean. X hat is a random variable with the sum of, it will become close to 0 eventually, but it is not 0, right? It's a constant. I'll take that out and the inner sum. Do you agree? X minus mu by sigma is nothing but equal to what? X hat minus mu by sigma into n. Yes or no? Correct? So you will be left with what terms? You'll be left with, so I'll get I equal to 1 to n xi minus x cap by sigma square as,
summation
yeah,
of
ask.
minus mu by sigma টাকে
Let me-
বললে মইনুলটা
Let me write the entire equation, then I'll come back to you. Minus x cap minus mu whole square by sigma square by n. Or let's write sigma root n. I have a reason for writing this. Now tell me, what is the problem?
means how do you write the summation I is equal to 1 to n xi
This
minus
one,
by sigma is what you wrote?
this term.
Yes, yes.
So see, this term is very simple, no? 2 into, so x cap minus mu by sigma, right? Into summation I equal to 1 to n xi minus mu by sigma. Right or wrong?
I is yes, right.
I just took the constant outside. This is a constant.
Hmm.
Now what will be the inner one? I can just multiply and divide by n.
Multiply and divide by n. Yes.
So now done. The inner one is nothing but x hat minus mu by sigma,
Yes.
isn't it?
Yes.
That's it.
So, and in
Others
that,
also,
uh,
yeah.
you write that xi minus x bar whole square by sigma whole square is equal to. I mean, Buzan, at the end you wrote the equals to a bit um, earlier
Where did it?
in the last line that summation of
This is so left hand side is this, right? This is your left hand side r.
oh acha हाँ yes
Left hand side is equal to r. I'm
Hmm.
just rewriting r in the left hand side. R equal to this. This is what I get, right?
Yes.
Now tell me, do I know all these values? Like if you have followed and you are revising things, this should be very simple. So this is what chi square n we found just some time before. Yes or no? This is chi square n. Real mu and sigma is there.
Yes.
What is this distribution? If you recall, this is, so let tell me x hat.
Of
If
that
this is chi square, I will tell you the answer. Then if see, let me see if you can tell me. It's chi square 1. So your r plus chi square 1 is chi square n is what I'll get. I'll use this later and then find the thing. But let me just tell me, why is it chi square 1? It's very important. We have done this in weak law of large numbers, if you recall. So in weak law of large numbers, if x, what is x hat? 1 by n, I equal to 1 to n, xi, right? Yes or no?
yes
So your what is the expected value of x hat? Again, I'm doing
mu
is equal to nu. What is the variance of x hat? This is equal to variance of 1 by n, I equal to 1 to n, xi, right? They are again independent. Yes or no?
sigma
So
square
this is 1 by n squared sigma square into n times sigma square, right? So it was sigma square by n. Yes or no? So the idea is, if you recall, as we take more and more samples, I gave so many examples as voting and then sampling for seeing the hemoglobin of a female population in a country and so on. So then your sigma x is sigma by root n. Yes or no? The standard deviation is agreed.
Okay, so I've written it as the normal distribution only.
Yes. So this is now our single normal distribution. Since these all are normals, xi's are all normals, mu sigma. So mu sigma square. So this is nothing but normal 0, 1. Okay. This is the normal distribution of the mean, right? This is the normalized distribution of the sample mean. Is it clear? So this is the mean mu of, again I'm writing x hat minus expected value of x hat by the variance of x hat. This is a normal distribution, yes or no? Is this normal or not?
Yes.
Others?
yes
Arthur, what is the problem? X hat k, you take some other distribution, it's still a normal, right? X hat is a normal. That we, because sum of normals is a normal. I told you to prove in your assignment, right?
yes
So this is a single normal, yes or no? This is going to give me a single normal. So now you see I get this equation r plus chi square 1 is equal to chi square n. So now help me to use MGF. How will I do? What will I do?
I'll
Tell me.
multiply by e to the
So I need to find the left hand side, right? And the right hand side. I can find the MGF of both. Yes or no? They'll be equal because their distributions are equal. Yes or no?
the MGF of both will be equal. Yes, yes.
Because the distributions are equal.
Hmm.
They're the same. We just showed now.
Yes.
We showed now r equal to chi square n minus chi square 1. Array, is it not true? I just took this on the left hand side. I got r plus chi square 1 is equal to chi square n.
Yes, it's true.
Yeah. Then what will it be? The left hand side will be e to the power t plus chi square 1. Yes or no? And right hand side, what will it be? Yes or no? I think it has stopped up for a bit. Let's just check. Let's just wait for a minute. Array, what is this? Just stop. Am I audible? I think my screen is not changing, right? Screen's frozen. Hello?
Yes,
audible.
okay now. Okay now.
Am I audible to you all?
Yes, Dadu.
But the screen is frozen, right? Is the screen frozen?
Are you writing anything?
Are you in that R equation, box equation?
Yes, as the expected value equation.
We are in the MGF equation. For me, in the computer, it's yeah. Now it's okay. Okay. So now what? How can I write the left hand side as? So now they are independent distributions. They don't depend on one another. I have broken them up. I can write it as product e to the power tr e to the power of chi square 1 is equal to e to the power of chi square n. What is the distribution? What is the MGF we found for chi square 1 and chi square n respectively? What is the distribution we found for chi square n? Does anyone note things down or not?
That 1 by 1 minus 2t square root whole to the power n.
N by 2. N by 2.
Yes.
And this is 1 minus 1t to the power half, right?
Yes.
So this is 1 by 1 minus 2t to the power n minus 1 by 2. So what is a what is our chi square n minus 1?
Chi minus 1.
This will be used extensively for all the tests that we'll do. In a small section, we'll do some t-tests and chi-square tests and so on. So anywhere you have sum of squares, it always is less than, in case of sample mean, it's 1 less degree, right? So remember this forever. This is a brilliant property. Yeah. So what is the property that we found? Let me write it in red ink and write it somewhere here. So Sx squared into n minus 1 by sigma squared is distributed as chi square n minus 1. Is it okay? This is why people use more advanced tests that we'll see. But is chi-square, all the intuitions and all the specialized distributions, all its properties clear to everybody? If it is clear, please go back and find the variance also. Like, can you tell me the broad intuition, how will you find the variance before I go on to the t distribution?
Variance of what?
The variance of the chi-square.
So it's E of x square.
I don't want to do. I have given you a very nice formula, mgf. You
Oh,
recall.
then double differentiate it with respect to t and put t equals to 0.
Yes, and then you'll get the second moment, and you'll have to subtract the first moment squared, right?
Yes, yes.
Good. And you'll see it's equal to 2n. Anyways, do these things. Now let us see what is known as a student distribution. And it will not be very clear until and unless we see the application of the distribution. But for now, let us learn this as a distribution itself. It was found by Gosset in the early 1900s, if I'm not mistaken. And do you know that this distribution is used in your ICSE exam to scale your marks? Even in your ISC exams or your JEE exams to normalize marks across data sets, across different test sets. Even in your GATE exam, they'll use the same distribution to get your, even in college, they'll be using this distribution to tell you which is in the tail, who is in the tail, and which is in the center, and grade accordingly. We'll see all these meanings. What do this mean? But let us warm up again.
Relative grading.
Yeah, this is always used for relative grading everywhere, and we'll see why. So in normal, there is a very, very fast decay. But in T, you can sort of think T has a longer tail. It has a longer tail, something like this. It will have a longer, we'll see, we'll derive the equations and see why it is true. But it has a longer tail, so it is more fairer to students. So if you use a Z distribution in a class of small number of students, you will get only maybe one person getting A plus, and others all will get, everybody will get B, because in normal distribution, everybody is mean. That's the idea. Okay, so let's see. The T distribution. Now I ask you a simple question to all of you. Do you also see that the close resemblance that these distributions have to the normal distribution? So all of these are defined on the normal, because by central limit theorem, everything converges to the normal, as Brahmajit has solved in the example that I gave in the class. You can go back and see the homework. But all distributions, sum of distributions, the means of distribution always converges to the normal distribution. Okay. Let us go and see what is the student distribution without further ado. So let us do it for a single, like a general case, and then we'll do it for a special case. So a general case is this. So Tn is defined as chi-square n by n. Okay. So in Tn distribution, Z is normal 0, 1. And remember, these distributions are there in your GATE syllabus. So please pay attention. So Z is normal 0, 1, and your denominator is average of chi-square, to put it correctly. So your denominator is 1 by n summation of I equal to 1 to n Zi square. Okay. Clear, everyone? What is the definition? As per definition, what is the student distribution? It's a single normal distribution divided by sum of squares of multiple normal distributions, right? And each of these are IIDs, as is the case for chi-square. So let us do a simple warm-up question. First question is, what is T of 1? What is T of 1? This is also a very important interview question.
One only.
Wait, T of 1 is Z by Z1 mod Z1, right? So let me write it once again. So denominator is chi² 1, yes or no? Chi 1, agreed? What
Yes,
is chi?
Yes.
What is chi² 1?
Z1.
That one.
Some normal distribution 1 squared, and you take the square root. What is the square root of a number? Of a square of a number or any number? The mod of that number, right?
Is the absolute value, yes.
X square root is the absolute value of x. Okay, so this is not Z but Z1. So now we'll define, so we have to find the distribution of Z by Z1. Brahmoji, Z non distributions don't cancel. So this is one distribution, this is another distribution. You will take their IID samples, right?
Yes.
So their IID. So you can take you will have a joint distribution of T. You will have Z and Z1's joint distribution. To be clear, let us rename these variables and write T as X by mod Y. Okay, where X comma Y are normal 0, 1. Okay. Now, do you understand why they will not be same? Because you will be sampling from normal 0, 1 on the numerator, and you will be sampling from denominator separately, right? Independently. They're not related to one another. So for example, you sample from the normal 0, 1 once, and you get 1.5, and that you put at X. Again, you sample from Y, you get 0.02, and you get this is the division that you will do, right? 0.1, 0.5 by 0.2. And now you have to find the distribution of what you will get for X by Y, right? Clear? Why it is not 1?
Yes, Dada.
Okay, then what is the distribution of T? So in the interview question, you will be asked a more general form, that is, what is the distribution of X by Y? It is more general. Let us see why. Let us do this question, then the above question is just a subpart of that. So it's the ratio of normals. What is the distribution of ratio of normals? Let us formulate the distribution first, and then we'll solve the integration. So first tell me, what is first step? What will I do? As we always do
We
when we, yeah,
take MG.
MGF. No, not MGF. MGF won't work here probably. It's going to give you the same. You have to find the distribution. What is the FT of T and F capital T of T? What are these two you have to find?
Yes, we'll
So,
do MT integral.
okay, you'll do a double integral or something. You'll do this, right? CDF. Always when I don't know what to do, I'll write the CDF. Yes or no? I have told you many times, it's not a 1-1 function, so it will not hold. The derivative rule will not hold. So we'll do directly CDF. Okay, Partho?
Yes.
This I have been doing like many times. So what will I replace? What will I replace this now? I do not know the distribution of T. That's what I have to find. Which distribution do I know?
FTT.
Do I know FTT? I need to find FTT. This is what I need to find. Need to find.
Yes.
What do I know? Which distributions do I know?
X and Y.
To find T, T is X by Y. I've defined.
X and Y.
So I know the distribution of X and Y, right?
Hmm.
They are normal 0, 1.
Yes.
So then what do I do? The next step is replace T by its definition. X by Y less than equal to T. Yes or no? Again, this is the millionth
Yes.
time
Yes.
I'm doing the same exercise.
Yes.
Okay, now can I just multiply Y? Say Y is not equal to 0 because a single number probability is almost surely 0. So say Y is not equal to 0. Can I directly multiply Y on both sides? That is,
Because
can I take?
distributions
Can I
can't
do?
be controlled.
No, but it's not about distributions. Y is the value of a distribution. You can multiply definitely. Can I multipy y's on both sides? That's my question. The value of the distribution can definitely be
No,
multiplied.
because y can be negative also. So the
Good.
sign of
Pay
inequality can
attention.
change.
Pay attention. Yes. So y can be, the distribution of y is this. Y can be negative also, minus infinity to infinity. Yes or no? Artho. Right?
Yes. Yes.
So there will be two cases. Yes or no? That probability of x less than equal to ty intersection y greater than 0 plus probability of, what will it be, Partho, tell me?
Probability of x greater than
X.
x greater than equal to ty intersection y less than 0.
Good. Now tell me, see, all the things it will turn out to be that you can essentially do what you were naively doing. Let's see why. So do you see, again, we have solved this, the symmetry of an or Gaussian. So x, say this is equal to ty, right? The x greater than ty is same as, do you agree? It will be minus ty, right? Y is negative, sorry. So yeah, so y is greater than ty, right? So do you agree it is equivalent to saying x is lesser than equal to minus ty? Yes or no? See, ty, for example, is this. Let us take ty to be this. The probability of x greater than ty. This is your ty. Is it not equal to probability of x less than equal to minus ty? If you take this as ty, this will be your minus ty, yes or no? Correct or wrong?
Correct.
Array, the tails are symmetric, yes or no?
Yes.
Others, no, not clear, you ask me, otherwise I'll not be able to understand. By symmetry, can I write this? And I have shown you this symmetry by algebra also. That x greater than ty when x is less than 0 is same as saying x is less than equal to minus ty when y is less than 0. Yes or no? I'll wait. Think about it. So I think there is a mismatch in the diagram. That's why you are confused. I wanted to make it easier for you, but since you want the exact diagram, let me just draw it anyways. Tell me. So you have this distribution of x, right? And you're trying to find some t into y, right? So fix y to be a particular value which is less than 0, right? Let it be some minus 5, for example. Correct? So this will be ty. Agreed? Yes or no? I'm plotting this function here. And x greater than ty is all this area. Yes or no?
Yes.
Similarly, what is minus ty? This is your minus ty. Same distance will be same. Just a mirror image. This is the mirror. Yes or no? So
Yes.
this
Yes.
points, do you see these two areas are still the same? That's why I had shown you the complements. So if this is ty greater than ty is same as less than minus ty. Yes or no? because they're the same tails on both by symmetry of normal. So now how will that help me? Can you tell me?
We
How
can
will
take
help that?
one and do twice.
Yes, so we can essentially write x less than equal to t mod y. Yes or no? It doesn't matter on the sign of x, y. Yes or no? If it is less than, I have put minus. So this is the definition of mod y. If it is less than 0, I put a negative. If it is greater than 0, I keep it positive. Yes or no?
Yes.
So you see, this is also equivalent to saying probability x by mod y less than equal to t. So this is also your Cauchy or t distribution, p1 distribution, which we had found here. So our general case, both of them have the same distribution. Mod also, if you have denominator as a mod, and even if you don't have denominator as a mod, both have the same distribution. Okay. This is also called a Cauchy distribution. Remember this. This is called Cauchy distribution. Okay. I hope that is okay. Now I'll wait for 1 minute. If this is intensive, please ask. Else I'll go ahead. Go ahead and ask. It may be silly question, but still ask. Because rest of it will be only calculation. This is the only math that is there. Okay, if it is clear to everyone, whom should I ask? Partho, you tell me. Why is it? Why did I write mod y?
So
Be loud and be clear.
I clumped two equations into two. So
Yes, because
so
y can
if
be both positive and negative.
yes, so since I can bring them into a single term that x is less than equal to ty if y is greater than equal to 0, and similarly if I bring both x in the less than equal to form and also x
Yes,
less than equal
correct.
to minus ty y
Good.
less than 0, so I can clump them up into a single equation here less
Because
than equal
mod y is equal to minus y if y less than 0 and y if y greater than 0. Yes or no? This is why I can club them up into
yes
the same equation. So your x by mod y has same distribution as x by y. We just now saw, proved. And same distribution as student distribution as T1 and same as Cauchy. So let us see the Cauchy distribution. How does it look like? We'll keep space for this. Mostly will happen in the last part of the class. This is the last part of statistics. But this is a very interesting problem. Generally, people are told to solve. So this is now there's a problem again. So I have been able to do it all right. But again, x and y are both distributions. I have to do it in terms of both of these are random variables, right? I don't know the value of y. So what is the solution to that? I can either do conditioning, which will not help, and like will be the same integral again, or I can do a double integral, right? Let us see how to do it. Let us do by conditioning or double integral, both are same, but let's try to understand the thing first. Say this same thing if I am going to write, okay, can I write this as probability of x less than equal to some ty? Now I know the value of say y is equal to some y, right, into f of y of y. Do you agree? This is your law of total probability. Yes or no?
integrated over all y's.
Integrated over all y's. So this is one way to do this question. That is, you condition on the values of y. That is, you get probability x less than equal to t mod y. And then you see f of y dy, and over all values of y, yes or no? Y's can be minus infinity to infinity, correct? Yes or no?
Yes.
This is nothing but what I'm writing x by, this is law of total probability, you're understanding, right? Why is this law of total probability? You understood? So if I condition on this, I have to write probability of y equal to y, yes or no? What is total law of total probability? X, if I don't know a probability of x and I can condition, I know the probability of x given a random variable y, I can condition it on y, and then I can write probability of y and do a summation or an integration over y, yes or no? This is the law of total probability we derived in the first class. What is probability of y equal to y? This is nothing but the CDF. We derived this as well. Is delta Dirac at y, yes or no? At y, what is the value of the small infinitesimal trapezium? Yes or no? So you get f of y dy. Correct or wrong? Ask na question if you're not clear. So the advantage here is I have put y equal to some small y, and this is known. Now it is known, which was not known previously. So this is why conditioning is known as the heart of statistics. If you know to condition, you can solve all problems. Do the assignment, you'll understand. Right? You have conditioned on y, you get x less than equal to ty, right? Any more doubts?
No.
Is it okay, Uthrij?
Yes, understood.
Okay. Partho?
Yes.
Not clear. Ask, tell me what is not clear.
Now it's clear.
Okay. So then what will I write the inner integral as? This one as? If it is clear, tell me.
This one
Like
I'm
minus infinity to t
Yes, minus infinity.
y f
Oh.
x.
Fx is?
Oh, মানে
Let me write fx, and then I will show you why it is true. Fx, fy, dy. Where is it? Fx, fy, dy, dx, or dx, dy, whatever you want to write. This is one integral I can solve, right? I can also do it in another way. I wanted to show you why conditioning is easy. But I can also solve it in another way. I can get this same integral. Can you tell me why? See, I can use the joint distribution of x and y directly. I'll bring this same equation and show you. What is the joint distribution of x and y since they're IID?
fx of x into f of y, yes.
Good. Like now, O3 and all, I think you were telling me how to do a double integral. You will help me to do the double integral. So this is 1 by 2 pi e to the power minus x square by 2 into 1 by 2 pi e to the power minus y square by 2. Yes or no? Agreed?
yes.
There will be a square root. Okay. So now,
Dada, it was
how?
given that they are independent, x and
Yes,
y.
x and y are from the t distribution. Remember, see, when I'm giving the definition, please follow. So what was the definition of t? It was a ratio of a normal, right? The z by a square sum of squares of normal, right?
Yes.
All of them were independent, and then we took n equal to 1 and we showed that it is equal to the Cauchy. Yes or no?
Yes.
And n equal to 1 Cauchy and x by y, we showed all those cases. Okay. So they are independent. Good. So now if they're independent, how will I write the integral? So I have to find the area for x. If this is x, this is y. This is your ty, right? So all values of x leading from minus infinity to Ty? Yes or no? How will you swap the plane? This is how we will swap the plane. And for all values of y from minus infinity to infinity.
Yes.
If you know, if you all of you who don't know to do a double integral, if you don't know, this is how you do it. So you fix a small y. Again, it's like conditioning. And for that particular y, as Otrij was telling me last day, you make all this, you calculate it for all values of x and y, right? Yes or no? So this is your x is equal to ty, some x equal to ty line. So all values of this these values will be of my interest. All this plane. So it's still y will be from minus infinity to infinity, and x would range from minus infinity to root ty. Here I have just written the opposite, just like forgive me. Sorry. Yeah. Let me just write draw the diagram once again to make it clear. So what is the region that we need? We need all the places. Area is the area where x comma y such that what is the value? X is less than ty. Yes or no? Is this the area we need?
Yes.
Correct. So then if I write a, so let my x be on the top and y be on the x-axis. So then this is your y equal to tx line, right? X equal to ty, right? Right?
Yes.
So for a particular value of y, for a say this is given to you. So a particular value of y here. So what would be the values of x? X would range from minus infinity to this one. Yes or no?
Yes.
That's what I am taking the integral of the inner area. This is how you do multivariate calculus integrations. You draw that diagram and then do it. And now you have to do it for all y's. Yes or no? All possible values of y. Understood? This is a particular y, y1. Now y2 will give you another line like this. Yes or no? X is equal to t y2. Similarly, again, for a particular value of y2, so this is your y2, you will get this area. And similarly, you will swap over all the values of y from minus infinity to infinity, and x will be from minus infinity to ty. Crystal clear?
Yes,
How
but
will
the
you
slope won't change. Will the slope change?
slope here? Slope is t, right? Oh, sorry. Slope won't change. So it's a function of x is a function of t. T is the slope. You're right. So at a particular, I thought y is the function. Sorry, y2. Very good. You're paying attention. Very good. So this is the area, other area. Yes or no? This is slope depends on this line depends on t. Right. Good. Is it okay?
Yes.
Okay. So then what will this become? What will this integral become? It will become 1 by 2 pi e to the power of minus x square by 2 into 1 by 2 pi e to the power minus y square by 2. This is your f of t, right? This is how we derived f of t, dx dy. But now you will tell me, Dada, this is as good as the initial starting point, isn't it? We don't know how to solve this itself. How will I solve it? Isn't it? You will tell me that. Any idea how will I solve it? So do you see that the integral that you have is only going to be a function of t? once you integrate it out? Do you see that? Do you, after you perform all the integration, it will become a function of t, yes or no? Because
Yes.
your inner limit is depend only on t, and x and y's will be integrated out, right? X comma y will be integrated out. That's what you had expected, yes or no? Because t was written as x by y, and you are trying to find t less than equal to t. So it should be a function of t only, not x and y, right? So that is a good sign if you are following me. Okay, now I know the integral. So I will write it in a small little integral. I will just separate things out. Say your y can be separated out, right? So the y is minus y square by 2. Let's keep things nice and simple. Then x is equal to minus infinity to t mod y e to the power of minus x square by 2 pi dx into dy, right? I can write this because this did not depend on x. So I can just take this integral out, yes or no? Just as we did for the summation. Is it clear this step?
Yes.
Now tell me, now it is only calculations, your integration skills. Can you use some well-defined, your class 11 and 12, can you use a well-known class 11 and 12 definite integral trick over here? Can you do it? I think you should be able to do it. Think about it. So what is this function? This is also known as the phi of t mod y, yes or no? This is nothing but the CDF of our normal distribution, right? Not following, tell me. Yes or no? I'll stop here. So we defined phi of z as the integral of minus infinity to z e to the power minus z square by 2. Right? It is the CDF that we have defined. We cannot integrate it. That's why we have a special name for it, right? This is a non-integrable form. I'll not proceed unless someone tells if you're following.
No, yes, understood till now.
Okay, now if you have understood, can you tell me what trick can I use? So if you tell me that trick, I'll go about the rest is just calculation. Do you see that this is an even function? Yes or no? This
Oh,
entire
yes,
thing,
yes.
this is an even function. So if you write this as some z or k, ky is same as k of minus y. So it's an even function. So as soon as I get this even function, I will be very happy. Why? So Krish, tell me.
Oh, that phi z equals to 1 minus phi of minus z that you
So
will
it will go from
use.
0 to infinity 2 times. It's an even function. E to the power minus y square by 2 by root 2 pi. And I can just write phi as ty instead of mod y. Yes or no? Because y is now greater than 0 always. This is why I am very happy. I have removed the modulus. Modulus is poorly behaved function, has a bad no derivative. So, oh, I told you we have to take derivative now. Now, isn't it? Modulus is a bad function. So I try to remove it. So I made an even function. So now tell me, what will I do? How this integration I cannot compute. Cannot compute. It is non-integrable. I'm telling you that it's intractable. So what will I do? Recall, this is your CDF. But if I can find PDF, I'll be still happy. Yes or no? This requires a computer. But to find PDF, what will I do? I'll differentiate both sides. Yes, this is the type of questions I think you may have solved before, where you couldn't solve the integral, you may have to differentiate. So 0 to infinity. So the outer integral is over y, isn't? Yes or no? So the differentiation will become a partial differentiation over t. Doesn't matter. Yes or no? If you recall, 0 to ty e to the power minus x square by 2 dx root 2 pi. Okay. Yes or no? Is it clear? When I take a derivative of an integration, which is not a function of that, it is a function of the parameters, for derivative with respect to the parameters, the integral, the derivative can be taken in the integral if the function is well behaved, and you can take the derivative of the parameters. Yes or no? If not, please go back and look at calculus 101. Okay. So now what will I do? Again, it's a partial derivative. This y doesn't depend on t. So it's e to the power minus y square by 2 dt ty e to the power minus x square by 2 root 2 pi dx. Now can I solve the integration? Can I solve the inner part? What will the inner part be?
Like Newton Leibniz will use.
Yes. So do you know this type of integration? Please respond. So what will be the inner integration? What is the value of the derivative? E to the
Like
power of
minus t square y square by 2 into
yes,
differentiation, that will be y. That will give y and
yes,
0
very
part
good.
limit.
So d into dty dt, that is equal to y dy. So now you see it has become such a simple. Now you can solve this integration or not? Minus infinity to infinity e to the power of minus y squared 1 plus t squared by 2. Yes or no? Correct? Is it right? Is this correct?
Yes.
I think the thing has not come up yet on the screen. Now it is correct, right? Good. So now tell me, can I integrate this? It's not minus infinity to infinity, sorry. It's from 0 to infinity. Can I integrate this? This is the last thing we are doing. Next day, we'll do statistical tests and complete half a class will be on statistical tests, and we'll start linear algebra next day. Because we have now all the tools, statistical tests will hardly take 40 minutes complete. Okay, so now how will I integrate this? Array, tell me, this is your integration. Class 11, 12 integration. Right? Simple integration, you're not being able to tell me. What will I do? Can I write this as dy 1 plus t squared over 2 and divide by 1 plus t squared? What is dy y square 1 plus t square by 2? Tell me, Utrij.
Yes, understood.
Now, what is this value of this derivative? Or this
Okay,
partial?
2y dy 1 plus t square.
2y dy
1 plus 1
1
plus
plus
t
t
square. Uh,
by 2. So this is equal to y dy into 1 plus t square. That's why I had divided this by 1 plus t square, right? Understood?
yes.
Good. This integration and all you should be doing in 1 second.
So I
So
was thinking this was the form of expectation of
it is
normal.
true.
And
Exactly perfect. Exactly. Very good. I was also thinking I'll do it that way. Very good. That also you can do. Expectation of normal and you will get the value. Same value you will get. Very good. Please, now your exam is over. Please go back and see the videos. You'll be able to relate everything. At least it's good that somebody is responding. Very good. So this one will turn out to be. So I can just write this as some x e to the power minus x square by 2 or minus y square. Array, what am I writing? Y. Yes. I'm just replacing this as some x. Right. So this integral goes to 1. As Outrich was telling me, this is nothing but the expected value of a normal, right?
yes.
Or variance of a normal, for example, for being clear. Variance of a normal. Expected value of a normal is still 0. Okay. But here, yeah, here you will get y square t square. So you will get t square. Yeah, you'll get that. Anyways, you can just this, but this integral is still 1 clearly because e to the power minus x from 0 to infinity is equal to 1 minus 0 is equal to 1. So now you see this integral. Now there's no more integral. Do you get the value of the x by y? This is your distribution of t as x by y. How does it look like? Let us first write the distribution. How does it look like? At infinity, at t equal to 0, if t of t is equal to 1 by 2 pi, right? 1 by pi, yes or no?
1 by pi.
At infinity goes to 0. So it looks still like a Gaussian, right? So if t of t or if t1 of t, the first student distribution looks like this, right? I have given you the second sort of chi-square. So just do it in your homework. It will become clearer also. So this is how it looks like, the PDF. Any doubt? Your normal is normally. I'll show you what is how the normal looks like. Anyways, so what is the CDF? Ft of t 1 by integral 1 plus t square dt from minus infinity to t. Yes or no?
Yes.
So what is this? 1 by pi tan inverse of t from minus infinity to t. Yes or no? Which is tan inverse half pi by 2 plus tan inverse t. Yes or no? Or it is half plus 1 by pi tan inverse t. Is it matching? Let us see if it is matching. Say put the value of ft equal to minus infinity. What will you get? You will get half plus 1 by pi tan inverse minus infinity is, what is it?
For the minus pi by 2.
Yes, half minus pi by 2 into 1 by pi is equal to 0. Similarly, ft of infinity is equal to 1 by 2 half into tan inverse infinity, which is equal to what am I writing? Plus, this is plus, so it's 1. So it is matching, it is correct. This is my CDF. So when I cannot find my CDF, I did the differentiation, found the PDF, and then found the CDF. One last thing, let us see, is what is the expected value of T? T1. So it's minus infinity to infinity T pi 1 plus T square. Yes or no? Correct?
Yes.
Okay, so I need to break it up into two parts. So let's take T dt from 0 to infinity pi 1 plus T squared minus infinity to 0 T dt pi 1 plus T squared. Each of these terms, look at this integral. What is this integral? 1 by pi
ln 1 plus t square
ln 1 plus T square
by 2.
by 2. Because I can write dt as 1 plus T square half. Okay. See now, at 0 and infinity, this does not converge, does not exist, right? Each of these integrations do not exist. Both of them in turn turn out to be undefined quantities. Therefore, this integral of T1, so the expected value of T1 is not existent, which means that the tail of this distribution is too large tail, right? So if you just integrate on the right hand side, the positive side, it is becoming infinity, right? This area is becoming infinity. The expected value of area, yes or no? Otrich or anyone, Brahmajit? This is going to infinity. We saw just now.
Yeah, the integral doesn't converge.
Does not converge. That's what I'm saying. So what does it mean? The tail is not a proper asymptote. Had it been a proper asymptote, the integral would have converged, right? It's still going on adding to infinity. So this tail is much larger. As I was telling, in student t distribution, tail is longer. That's why you don't have the expected value here. So your z square looks something like this, very fast tail. This is your z square, right? It is 1. And this is equal to 1 by pi, right? So do you see why I was telling the tail is longer for a student t distribution? So I showed you for T1, the tail is very long. That guarantees the distribution must be flatter because the area has to be still 1. The expected value is not converging. The tail is long. This is equal to 1 by pi. But this is your normal distribution, very fast convergence. This is 1. This is normal 0, 1. This is your T1. Okay, now tell me, as somebody was telling, as n, I think O3 told me, as n goes to infinity, this T goes to n. Let's see why it does it happen. So Z by chi square n by n. Okay, this is how we define the student distribution. Yes or no? This is the last section, last part. Maybe 1 minute it will be required. Is it okay?
Yes.
This is your student distribution. Now you tell me what will happen to chi square n by n as limit n tends to infinity. What will happen? It is summation of I equal to 1 to n zi squared 1 by n. Yes or no? Correct?
Yes.
So what did we show in weak law of large numbers? That sample mean will converge to
Actual mean.
Sample mean converges to actual mean. In weak law of large numbers, we showed. So what is the actual mean? Expected value of Z1 squared. Yes or no? Right?
Yes.
What is expected value of Z1 squared? We found this is nothing but
One.
variance of a normal one, or the expected value of a chi-square 1. We found it already. So it's 1. So this denominator has to go to 1 as n tends to infinity. Therefore, t infinity is nothing but z. So you see why this goes upwards to normal. So the student t distribution you'll see in the tests next day. When n becomes larger, you can use the z distribution directly instead of student t distribution. We'll see why we are taking a chi-square in the denominator next class. We'll see, and then we'll finish off statistics. So we are done with all distributions and all theory of statistics, and we'll just see what is the application of these for next 30-40 minutes in statistical tests and confidence intervals. With that, I'll stop today. Any questions? Okay, I'll stop recording then. Okay.